In this video, we're going to take a look at how we take a pre-trained model and fine-tune it or do post-training on it so that it's suitable for a lot of different downstream tasks. So the agenda is as follows. So we'll look at fine-tuning. We'll look at different techniques for fine-tuning, RLHF, reinforcement learning with human feedback, instruction tuning. We'll also look at hallucinations and how we address them. And finally, how to use tools from a foundational model. How do we train them in order to be able to call these tools? Okay, so think about a pre-trained model, right? So a pre-trained model is a model that has seen a huge amount of data and has been trained on that data, and it knows how to predict the next token, right? So it's just a next token predictor. It's not a assistant or it's not a chatbot for you that you can interact with. And fine-tuning basically takes that model, which is the next token generator, and then it basically transforms it into a chatbot or an assistant. Usually the post-training is much more cheaper and faster compared to the pre-training phase, right? A lot of effort is actually spent in pre-training, but post-training is lightweight in comparison. So for conversation, in order to train a chatbot, the way it is fine-tuned is very simple. We take the base model that we saw. So we were looking at a conversation with the base model before where we asked it a question, what was the capital of France? And it just went on and gave us an article rather than just giving us an answer. It gave us the answer as well, but it just kept on going and going, right? So how do we take something like that, and then how do we convert into something that is suitable for conversation? Well, the answer is simple. We essentially show it a lot of different conversation dataset, dialogue datasets, which makes it into a chatbot or an assistant. To do this post-training, one of the techniques is called reinforcement learning from human feedback, and it's exactly what it sounds like. So we ask our model to generate text, we ask it a question, and then we rate the response. If we like the response, we give it a positive response, otherwise we give it negative response. The responses, if they are not helpful, if they're harmful or unethical, then we rate them in a negative way. But reinforcement learnings happens in a huge scale, right? So which means that a human is not available to rate the responses of a foundation model all the time. So to substitute a human, what happens is usually a reward model is trained, which basically learns how a human would prefer, what kind of response would a human prefer. And once the reward model is trained, the reward model is essentially basically just trying to emulate the human preference. These two models, the base model and the reward model, can then be left to do reinforcement learning, where the reward model will teach the base model to give responses which humans would probably like. So this is how it works. So the model generates response, the reward model will give a feedback, and then the model's weights are adjusted. What are the benefits of RLHF? Well, it's you're aligning your model with the preferences of a human. So let's say you are building a model in China and you don't want the model to say anything bad about China or the government there, then you'd show it a lot of sample conversations where you would ask it questions like, what happened in Tiananmen Square? And the response would be, I'm sorry, I can't help with that. So with these conversation pairs, you can have the model not talk about that thing. It's not just about China, but if it is about things that we don't want model to go into, like violence or about harming a human potentially, then we teach the model using RLHF to not produce those kind of responses. It also generates more human-like interactions. So it's a really critical step in order to make a model feel more human. Another post-training technique is called instruction tuning. And instruction tuning is where we teach the model to follow instructions, right? So basically to take the question or the prompt and then act on that prompt rather than just trying to predict the next token after the prompt. And this is what an example data set might look like. So you might give the model translate hello to French and ask the model to make a prediction. The expectation is just bonjour rather than a long article. Similarly, you might have a prompt about summarizing and you might have an expected output, which is actually a summary written by a human, and LLM learns from that, so that I need to respond to questions like these with summaries like these. And same with poems and heaps of other different cases as well. So as you can imagine, the data set needs to be really broad, and it needs to have a lot of different diverse input-output pairs so that the model can learn to follow instructions rather than just act like a token predictor. Hallucinations. If you've used LLMs at all, then I'm sure you've run into hallucinations. This used to be a big problem in the past, nowadays less so, but it is still a problem. But hallucination is where a model is producing text, generating text with a lot of confidence, but it is wrong. It's not factually correct. It sounds correct, it's grammatically correct, and it works, but it's not factually correct. So how do we fix this? Again, this is also something that can be solved by using reinforcement learning, not fully, but it can be improved. You can also use things like grounding your LLM so that it's referring to the outside world in order to make sure that the response is in fact truthful. Another approach is where we ask a model a question, and if it hallucinates, if it doesn't give the right answer, then we basically ask it to say, I'm sorry, I don't know the answer, rather than just randomly saying the answer. To do this kind of training, you would essentially have another model which is a larger model and knows the answer to these kind of things and can detect when the model has hallucinated. And in that case, we can just have a data set where to all of these questions where the model has hallucinated, we can just ask it to respond with, I'm sorry, I don't know. And we can also teach our foundation models how to call tools, right? So calling tools is, rather than just producing text in response to a user's prompt, they can actually call external tools. LLMs famously, have no access to the latest data because they only have been trained on a data set which has a cutoff. So we can give it tools like internet access, web search, and things like that. But how does that work? How does this happen? Well, again, we use a data set. We show an input and we show an expected output. So this is how we teach the LLM foundation model to call tools, right? So when it sees some particular input and it has access to some tools, then we teach the model to call those tools. And with these kind of post-training techniques, what we have is a much more instruction following model, which can be used as an assistant or a chatbot. And not only can it respond your questions, it can also use other tools in order to supplement its capabilities. In the next lesson, we will look at the ethics around building LLMs, and as a software engineer, how can you use AI responsibly to build your applications? Thanks.